All right, Steven, you can tell us a little bit about you and give us a lead into your talk.
Yeah, so I've been working with D since about 2007. Started with D1 and Tango, and then moved on to D2 pretty quickly after that. I don't know, I've been just contributing little bits here and there to the standard library. I would say probably my most interesting project is iopipe. The language is great for me. After I've used D, I don't want to use any other language, so that's why I'm here. That's why I keep coming back.
So, what's up with the talk?
So the talk is about trusted code, and trusted code is deceptively hard to get correct. The main thrust of the talk is that when you have trusted code, the whole point of having a trusted function is so you don't have to check your safe functions. If we didn't have that, then you could just let safe functions call system functions. That's fine. But the idea is we want to just have to check our trusted functions. Other than that, there's no point to it. So it's really hard to write a trusted function that doesn't make it so then you have to go check all your safe functions. And I think that's really the main thing I hope people take away from it.
Well, this has been on your mind for a while, apparently, because you wrote a blog post about this in 2016. What's made this stick in your head for so long?
It's just that I really like the idea of having a completely safe system to work in. I think Walter agrees with that, and Attila agrees with that. You want to work in a place that's completely safe by default. If you need to get outside of safe, then I want to mark with big red flags and police tape. Don't do anything here. You need to stay away from this spot unless you really know what you're doing. I think there's a lot of code in Phobos that has been marked with trusted just to get it like, oh, we can apply safe. Oh, if we do that, this doesn't work. So, we'll just tag that as trust and we'll deal with it later. And I think that's kind of not the right approach to have. Unfortunately, we didn't start with safe, right? If we started with safe by default, it would have been a lot easier. And maybe even the approach to safe, if we had a whitelist instead where it's like, by default, nothing's safe, but these X features are safe, then might have turned out differently. But I think still the things that I'm going to talk about in this talk have kind of not as much to do with that. It's just to do with the fact that what we treat as safe is whatever the compiler thinks is safe. And there's no way to tell the compiler, well, actually, even though you think that's safe, it's not. Because I have this trusted code that's expecting X, Y, or Z.
Are you using safe and trusted extensively in your own code?
I'd love to. My day job that I have a vibe database system that runs on MySQL. And right now, MySQL is not marked as safe pretty much anywhere. Part of that is the fact that it uses variant, which can't be safe. So I actually have a PR pending that is going to be pulled pretty soon. Nick Soblowski just handed me the reins to the MySQL library because he's kind of burned out on doing it. So I'm going to be taking over that library. And once my PR is pulled, then you'll have an option to use safe code. And really, because so much of my stuff deals with MySQL, I can't really make the whole thing safe until that's in there.
Do you think that's kind of a big blocker in general? Is that there's somewhere at the bottom of the stack there's a
Yeah, for sure. If you use a library that's not marked safe, and that's kind of the thrust behind making safe default, because most code we write is safe. Just about everything you write is safe. You're just multiplying two numbers or whatever, it's safe. If you don't mark it that way, then the compiler's not going to treat it as safe, even if it is. That's the big problem there.
What do you think about the whole default for C functions?
I think the approach that Attila outlined is perfect. If it has no body, you have to mark it. I think that's fine. You have to say this is safe, system, or trusted. I know there's some people who say, C functions can never be marked safe. They should be marked trusted. I don't care. That's fine. Whatever works. But as long as it's not, you flip a switch and all of a sudden things that are actually system becomes treated as safe without any checking. That's the one thing we couldn't live with.
You got a question in the live stream chat. Isn't safe inferred for some functions?
Yes, it's inferred for auto functions and template functions.
Do you think that safe covers all the bases that it needs to cover?
So possibly if you add dip 1000, the live function or some ownership borrowing thing like that, and as I'll get to it later, another dip where you can tag data as system data, I think it could be good enough. The thing I've read is the interesting thing about Rust, right? So Rust is like the gold standard now of like, this is how you do memory safety without problems, where the compiler makes sure you can't have memory problems. And what I've read is that in order to do anything interesting, people have to escape out of that all the time. So it's like, what's the point?
What's the point?
Now destroyed that. I think you're never going to get to the point where it's provably safe. you're still going to have some amount of manual review no matter what. And it's just minimizing that review.
What's your take on trusted blocks?
Trusted blocks are fine.
That we don't have. What I mean is we have to use the delegate workaround,
Well, that
lambda
is a trusted
workaround.
block.
Well, I mean,
Right. It is a trusted block.
yeah, but what? Okay, let me rephrase that. What do you think about the idea that we should have syntax for trusted blocks other than lambdas?
It's okay. I don't know that it's that enabling that we need to do it, because right now, I believe in all the compilers, even without optimization, if you declare a lambda and call it immediately and don't store it anywhere, it's just like you wrote it as a block. Like it's all inlined completely.
Okay.
Walter, you might be able to answer that question.
It's inlined if you, well, with DMD, if you use a dash inline switch. But yeah, it'll be inlined. Unless you do something like have loops in it or something like that. If you just want to have a trusted block to do something simple, like a cast or simple if or something like that, yeah, it's going to be inlined. But it is subject to the limitations that the DMD inliner has, like it won't inline it if it's a loop, except under certain special cases. Eventually I'm going to fix the inliner so it'll inline a lot more, but if you sort of shrink wrap the unsafe thing you're doing around the lambda, so it's just an expression or something like that, yeah, it's going to inline and you're not going to have any problems with it. The reason I don't want to make it another language construct is I kind of want it to be ugly to use trusted blocks in there. They should be ugly, and it should motivate people to try to minimize their use. And they should stand out too, being ugly. So that's kind of the motivation there. It's the general idea of doing the right thing should look nice and doing the wrong thing should not look as nice, kind of theory of programming language design.
And I guess that's my follow-up for Steve. He just said that he thinks trusted blocks are fine in general. Now you just explicitly said, Walter, that they're the wrong thing, and that's, I mean, there is some thought that we shouldn't even allow trusted blocks in the language.
Well, it is a subjective opinion. I mean,
Right,
there
right.
isn't any wrong answer here.
I didn't necessarily mean that trusted blocks were okay to use all over the place. What I more meant is that trusted blocks are okay syntax-wise. I don't think we need to add a special feature to allow trusted blocks versus using the trusted lambdas.
Okay, so but you think they should be minimized in their use? You think it's a code smell?
Yeah. You should not use trusted blocks unless you know what you're doing, because really a trusted block kind of poisons the whole function. Once you use a trusted block, you now have to review all the rest of your code in that function to see if somehow there's an interaction that causes that function to be unsafe.
That's another good point. Just because the operation is untrusted, you're right. You have to review the entire rest of the function to see that the parameters you're passing to that trusted thing are also safe, because your trusted block may not necessarily have a safe interface to it. Normally, when trusted is confined to, at the function level, you can have a safe interface to it, but a trusted block can be accessing, because it's a nested function, all the random variables in your function, and it can access them unsafely. So that's a good point I hadn't thought of. Having a trusted lambda inside your function means you have to review your whole function. Unless, of course, you make it a static lambda, then you're in better shape.
Right, if it's a static function, you control the interface at that point.
That's right. Then you should set it up with a safe interface, and you should be fine.
Right. And there's some people who've argued on, in pull requests and stuff where we talk about trusted stuff, that it should only be that way. Like it shouldn't. You should never mark it trusted if you can't have a safe interface. And I think that's a little bit too far.
Yeah, that might be a little bit too far. It definitely should be in somebody's style guide about how to use trusted blocks. But yeah, I think that's up to a style guide kind of issue, at least for now.
Question in the live stream: why aren't we allowed to take the address of a local if escape analysis can prove the reference will never leave the function, or alternatively that the stack frame will not disappear within the lifetime?
You can with that live code. That's the short answer, because it does a data flow analysis to check it.
Question in the video chat: cannot access array elements out of bounds. He's referring to restrictions in safe code, I believe. Does that mean that safe functions always have bounds checking at runtime, or does that mean that the compiler needs to prove that the access is in bounds?
It's runtime. It's a runtime check. That's probably one of the only things that safe requires that is runtime. Everything else is compile time.
I think there's some dynamic casting of class hierarchies that factor into that as well, but I'm not sure.
I think dynamic casts always work because they'll return null if they don't work.
It is true, though, if the compiler is able to prove that the indexing is within the bounds, it can skip doing it at runtime.
That is very true. If it's, let's say, a static array of 256 values and you have a ubyte that you use as an index, you can say, okay, I don't need to check this.
Some optimizers will also look at your loops and will see if, I is less than the length of the array, it can skip the bounds check inside the loop body.
Right.
DMD does not do that, but I believe GDC and LDC do that.
Steven, issue 2655 for the tagged union. This is the regression on the slide, and the slide just went away, but the compiler accepts unsafe code in a tagged union.
Yeah, that was the one where I actually started writing my talk and wrote my code to say, okay, here's my attempt at a safe union, and I'll say, okay, and now I'll tag the unit test as safe, and it won't compile, and then it compiled. And I'm like, wait a minute, that shouldn't happen. Then I found this bug where in some cases it infers that a function is safe even though it's accessing a pointer or an integer as a pointer.
So my question was, this is a regression from 272. Have you did you look at it at all?
No, I'm not a compiler.
Yeah.
No.
So is this something we should prioritize?
Oh, everybody's bug is top priority.
I mean,
this is a memory safety bug. This is your bugbear.
Yeah.
Yeah, I know. Occasionally, I'll just look at everything tagged as safe and go through the list and fix them, but I don't do that all the time. But I really like the keyword categorization of bugs on Bugzilla, because a lot of things in the compiler you need to sort of get up to speed on that section of compiler again before you can fix bugs in it. And if you can fix a whole bunch of related bugs in the same section, it's a lot more efficient to deal with them that way. That's why, maybe a month ago or so, the inline assembler is a complicated, ugly piece of code, and I decided to simply fix everything in Bugzilla that was related to the inline assembler. And once I got up to speed with how the inline assembler worked again, it was pretty quick to dispatch all of the bug reports for them. So any safety issues, it's real important to mark it with the safe keyword on Bugzilla, because a lot of them are related, and fixing one may give you a clue also for how to fix the next one, and it just makes things more efficient.
Okay, for posterity, we have a follow-up question to the earlier question about bounds checking at runtime, and the follow-up was, can I turn it off? If I can, doesn't that then violate safe? If I can't, doesn't that hurt my performance? And Steve typed an answer already, which is?
I think you can turn it off if you turn bounds check off, but it might be set up now that safe code still will have the bounds check, but I haven't tested that.
Oh, you can turn it off.
You can turn it off. So yes, it will hurt your performance, but it's not worth it.
Well, the reason is so you have a way to check to see what its impact is on your performance. Okay, if you can leave everything else the same and just turn bounds checking on and off, then you can benchmark and see what it's costing you to do the bounds checking.
I'm going to look this up, but I'm pretty sure there's a parameter to say bounds check only in safe code. Is that right?
Maybe that was added. I don't remember.
Yeah, there's bounds check on, off, or safe only. So if you turn it safe only, it should be on.
Yeah, I remember that now.
Okay, we got a couple questions from the live stream here. Is there a Bugzilla category for new contributors?
No.
Another question for Steven, what's your plans?
You mean for new contributors, like to look at bugs?
Oh, right. There's like an easy category or something,
there's like
right?
a boot camp, right? Isn't
Right, yeah. Steven, what are your plans for iopipe? Do you plan to propose it for inclusion in D runtime or Phobos?
My plans for iopipe for now don't include that. I'm hoping to get iopipe to a point with the std.io library that Martin started to make it so that I have like a complete replacement for Phobos IO. At that point, I don't know if I need to include it in Phobos, but it would be cool to have it as an option for people to use.
So why aren't destructors safe?
No, what I meant was destructors might not be safe, but I had marked the function that called the destructors as trusted. So you could end up passing in a type, that has an unsafe destructor, and then now you've trusted that without because it's part of the template. So you got to be careful with that. So that's why I abstracted it out.
Can iopipe be used with vibe.d?
Not yet. That's my next thing, is I want to make iopipe or std.io have a driver for at least one fiber-based asynchronous driver. And Vibe would be a great target. The only thing is Vibe already has buffering and stuff in place. So I'm not sure how that will work, but I'm sure I can use the underlying event driver for event core as a base for my driver, and then I can write iopipe on top of that. And then it should be seamless with Vibe. Yes, I would love to do that. I'm kind of sad that I can't use it in my normal code.
Okay, this one on your "Are we done" slide, this one jumped out at me when I was reviewing the video when you first sent it to me, and I was surprised that there is a situation where if you have, in some cases, trusted code, you actually need to review not just the function but the whole module.
Right.
Was this something you learned the hard way, or?
It's something that has come out in PR reviews in Phobos. I don't know this guy's name, but his handle is like AG0P something or other.
Right.
I'm not sure.
Yeah, I know him in the forums. Yeah, don't know who it is.
Yeah. We had a discussion over basically a similar tagged union. There's kind of a tagged union in Phobos called choice, which basically takes two ranges and based on a Boolean mimics one of those two ranges, and it stores it as in a union. So basically, it's a tagged union. One of these is valid, the other one's not. And there was a lot of discussion on that, and that's kind of was the inspiration for this talk, is like, if you can change the tag, then you've violated all the trusted code that's in there. And because the whole file has access to the private data, you can't encapsulate it in there. You have to review the whole file. It's unfortunate that that's the way it is, but that's the way D works, so we have to deal with that.
I wonder, Walter, were you aware of that?
There was a fair amount of discussion a few years ago that I participated in on trusts local effects that can spread outside of the function, but it didn't go into private issues that I recall.
Yeah, the problem here is we have basically you're encapsulating your safeness into a type and hiding the trusted parts behind the private data that you can only access from trusted functions. But the problem is the whole file can access the private data, so you still have to look everywhere. And in some cases, you have a file that has lots of code that doesn't deal with that function or doesn't deal with that type. You still have to review it. You still have to look at it and see, is there some code in here that's accessing private data that shouldn't be?
Yeah, there's been some discussion, not necessarily about trusted, about D's ability to access private data from functions outside the class but are in the same module. And my argument with that is if that's a problem for you, those functions should go in a separate module.
Yeah,
there's no reason to program D code like you program C++ code where you lump everything into one file. There's just no reason for it. There's the module constructor. The module is, shall we say, the scope container for it, and the module structure is meant to be used to help isolate things from each other that shouldn't be looking at each other's private data. So if you're having that problem with your code, I would suggest a refactoring into more than one module, and you put your secret stuff into a separate module.
I'm a big fan of the private to the module. I like that, but I think the surprise here is that it's a potential hole in safe.
I don't view it as a problem, actually. I think private for the module is correct.
Right.
I like that. I think there's other ways to fix that problem. Actually, I'm talking about it now on my talk.
Yes.
Attempt 3.
We have a question in the live stream for both of you. Currently, derived class destructors don't have to have all the attributes of the base class. What do you think about fixing it? For example, @safe destructor in the base class can be overridden by a system one.
That shouldn't be allowed. If that's happening, it's a bug. Wait a minute, I think I have that backwards. It's always confusing to think of covariance and contravariance. Yeah, I think that is not a bug.
I think it is not a bug for a destructor because a destructor is not something that's virtual.
Yeah, and the destructor, a system destructor can call a safe destructor for the base class.
Yes.
But the other way around can't happen. If you derive it and make it safe, then it can't call the system destructor of the base class.
So, okay.
So the idea is in a derived class, you can loosen restrictions, but you cannot tighten restrictions.
The question here, wouldn't that prevent having a safe destructor member in a subclass? And yes, it should prevent it. That's the point.
Yeah, I had to think a lot about this to convince myself that it worked and that it was sound.
opBorrow. What would you expect an opBorrow to do, Steve?
One of the things that I talked about in this part of the solution is I think that there's still some things you can't duplicate in a struct, and possibly a struct could say, this thing borrows from me, and maybe there's an op return to give it back. Because one of the things that I think the @live solution solves for many cases is, you have two references to the same thing. But what if you have two references to the same thing, but they're of different types, which is what's happening here for a tagged union?
It doesn't care what the type is.
Yeah, but how does it know that it's the same thing then?
Because
Like,
of
how
where
do
it
we
came
tell
from.
it came from two different functions?
So the question is kind of, if I pass two different references to a function and then return a reference, which one does @live think it comes from? And the answer is both. So it will assume it comes from both, and so it will not allow any other live references to either of the two arguments. Now, in Rust, you can have an additional annotation to say which one it comes from, but I decided that it wasn't really necessary to have that. I may turn out to be wrong, and in which case we can always add it. But I'm going to see how far we can get without having to add an extra annotation like that.
We have a question here. I can answer this one actually. Is @live and related work the implicit successor of DIP 1000, which has been superseded? And that's not actually what the superseded means in this case. DIP 1000, the feature was not superseded. The proposal was superseded by the implementation. What that means is the implementation of DIP 1000 no longer matches the proposal. So that's where the superseded comes in. @live is not a successor to DIP 1000. It is an extension of DIP. It's built on top of DIP 1000. Did I phrase that correctly, Walter?
Right, it builds on top of DIP 1000. DIP 1000 is part of the core language, even though it's still only enabled with a switch. It's supposed to be part of the core language. There was talk yesterday. It's been sitting around as a switch long enough. We should just go ahead and put it in as part of the core language now.
And he goes on, he says, referencing an earlier question, @safe taking the address of local works with preview equals DIP 1000, but not with the @live annotation.
That's one of those things I'd have to think about. So I'm going to defer an answer on that.
Well, I've got a question from somebody. Oh, I'm sorry. Go ahead.
I know the compiler in some instances, if you take the address of a local, it will implicitly add the scope annotation to it. So that may be what he's referring to there.
While we're waiting for questions, Steve, do you have anything you want to say to kind of close out the talk there?
I hope we get that DIP 1035 in. I think the @live looks very interesting and useful. We have all these things that are, as my dad would say, in the hopper, ready to go. And I think we need to get that safe stuff. I think Walter was right when he said, maybe not right about that it will kill C, but that it's going to be one of the most important things. People are just sick of fixing, the heartbleed bugs and all those bugs that happen that take down so much of the world. They're just not going to put up with it anymore. And we can position D to be maybe not the bulletproof, unbreakable thing, but the compiler that helps you make sure you write safe code. I think it would be a very good position to be in.
Yeah, and you can pick any widely used C library, like image loading libraries or networking libraries, and look at their changelog history and how many updates were for.
I found it very interesting that, like, I went to look. It's like, okay, I'm sure I'm going to find some safety bugs, and I found both Google and Microsoft 70% of all bugs, like exactly that number.
Yeah.
70% of all bugs were memory safety bugs. Yeah. So I thought that was interesting.
And they just keep coming.
And a large number of those are buffer overflows.
Yes.
That's the number one bug in C code, is memory or safety bug in C code are buffer overflows, and D's nailed that one for a long time. So with @live, we're just kind of picking up the remaining pieces.
Question for Walter and Steve. Andre mentioned during the review of DIP 1035 that the unit of encapsulation in D is the module, and that private should become more strict instead of introducing system for variables. So what do you guys think of this sentiment?
I don't like it because still, I guess it still means you have to review all of your safe code that's in the structure then, right? So you still haven't escaped the fact that I now have to review functions that are completely marked safe and there's no trusted escapes inside. I don't like that idea. I want to review as little as possible.
I think Steve has it exactly right. You want to review as little as possible, and if you find you're having to review too much code, you should, with safety issues, you need to split things into smaller modules or smaller functions to get better encapsulation.
Any more questions?
Here's another one. We talked earlier about STD2, Steve, and I was asked about the status of it, so I'm going to defer that to you.
Yes, so I admit that I'm also procrastinating just like you were and haven't done anything yet. But I think we're at a spot now where we're going to, that I can actually make it work even without some compiler help using what we're going to use as mixin templates as we talked about in the emails. I think it's going to look pretty nice, actually.
Yeah, I'm excited about it.
My first step is to try it out, see how it will work. The things that I was working on in terms of getting rid of auto decoding. And
yeah, auto decode must die.
Yes, for sure.
In terms of safe and trusted, what questions should people be asking right now?
Basically, what can the compiler do to help me write safe code? Safe by default, dip 1035, dip 1000, making it the default, the live code at live. That's the question you should be asking yourself. Like, how can this compiler help me?
Is it worth it for me to annotate functions with @safe right now? I'm talking about things the compiler can assume for optimizations.
Yes, annotate safe as much as you can, whether or not the compiler does anything with it. It's good to do that.
The only thing I would say is not templates. Templates should be inferring without the bug we talked about earlier. It should be inferring safe anyways.
You're right.
If you mark them as safe, then they'll stop compiling for things they should compile with. So.
Well, which is good.
Yes. But sometimes your template is just a template. It's not intended to be dictatorial about everything must be safe.
Well, it depends on how hardcore you want to go about being safe.
Yeah, for sure.
In fact, I think just simply annotating all your code with safe and then seeing where the compiler complains may be eye-opening, because lots of times you can make something from system into safe without sacrificing anything.
Correct.
For example, if you take a string, or if you take an array and you go .pointer, that's not safe, and that will be a flag. But if you replace the thing with the address of the array sub-0 with 0 in brackets, that's actually considered safe. Then you can use the safe annotation with that. It is allowed to take a pointer past the end of an array, and it's specifically allowed to, so you can do things like loop until the pointer runs over the edge of the array. You just can't dereference.
No, that's actually not allowed. Can't take a reference to past the end of the array. Because, well, you can, but it'll trigger the bounds check, and the bounds check is going to say no.
Yeah.
Is consistent documentation of current and emerging features a barrier to users writing safe code?
I guess I'd have to say it is a barrier, because if you get a compiler message and it doesn't make any sense, well, that's not very helpful.
Yeah, and I went over that in my talk when I said, okay, I've written this template, and I just marked the unit test safe. It all of a sudden it just says, oh, I can call this system function. Well, that doesn't help me because I don't know why you marked that as system. So if there was actually a feature that the compiler could say, you could tell the compiler, I expect this template to be inferred safe. Tell me why it didn't get inferred safe, rather than me having to go and mark it safe and recompile.
Well, I'm just going to say that's how you do it. Yeah, mark it safe and see where the error comes from.
And that works. That works for the most part, but sometimes you're not the one who wrote that template. So you're importing it from some library. A lot of times I have to go into my dub cache and go mark things safe so I can figure out what the hell's going on.
We have here a question basically about attribute hell. D has a lot of attributes. I see functions with attributes slapped everywhere. Are the defaults sensible?
There's a lot of debate about that.
I think I posted this in a newsgroup post. It would be great if no throw, safe, no GC pure was inferred by default, and you just turned it off for when you didn't need it, because that's I think just everything should be inferred by default, and you just mark it if you want it to be a different way.
Question: do you think shared libraries can be trusted? And he gives an example here that bindbc loads dynamic libraries using G-shared function pointers, so you can never call them from safe code, even if they have a safe interface. So can shared libraries be trusted? I think it's different if you're loading them dynamically or if you're loading them statically. So, I mean, if you have a static interface where the system's loading, I think that can be trusted for sure. But I guess this really applies to loading manually.
I don't know how bindbc works, so I'm not sure.
Basically, I just load function pointers. I declare the function pointers to be G-shared. They got to be shared across threads. And I just do a DL open, then load the symbols. And
that happens in thread construct?
No, that happens when you call load. You have to manually call the load function. Yeah.
As long as it's properly mutex or something, it should be fine.
No, but I mean the G-shared can't be
allowed in
safe.
code.
It's not allowed in safe code, but you could trust it. You could be trusted.
I guess the only way to do that, I'd have to make the function pointers thread local.
You could do that.
And then you'd load the DLL per thread, but man. All those function pointers.
Well,
that's kind of...
if you say, oh, we'll just look the other way and let you do it safe anyway, then safe doesn't really have much meaning to it.
Yeah, so I guess the answer, I mean, is there a way to do this that makes sense to where you can have a safe
this is what
interface?
happens. People just start marking things trusted because it's like, well, I know this works. I think Attila said the same exact thing in a forum post. Is like, I just put things, I was marking this trusted. We were talking about dip 1028. It's like, yeah, well, then there's bugs, and I think I pointed out a couple of bugs in his code because of that. And people just slap trusted on because they just want to get it to compile. It's compiled before, now I want it to compile now, and I put safe up here, but in order to get it to work, I just put trusted on it. But if you don't think about what that actually means, then you're going to run into problems.
Yeah, Snarwin Paul is saying, shared libraries can be trusted to the same degree as any external library. If you know from its documentation specification that it has a trusted interface, you can mark it trusted. But like I said earlier, I think that's only true if you're letting the system load the library. And you're just using, regular function declarations.
More about the loading of the library, not
manual. Yeah. If you're loading dynamically by yourself, you're calling DL open. In that case, I don't see how it can be trusted if you're going to provide access to those function pointers across threads. Can shared be trusted? G-shared can't. Can shared?
Shared is safe, I believe, unless.
So if I change the function pointers from G-shared to shared,
then technically you shouldn't be able to use it then, right?
The problem is you can't load it then.
Okay, that's why I went with G-shared in the first place.
Yeah, G-shared is basically shared but without the type information.
Yeah, so Dennis is saying here, another way to phrase my question, can my OpenGL application ever be safe? I use safe and leaf functions as much as possible, but I feel my application as a whole is doomed to be system.
It may be, the DMD source code, I've tried to make it safe, but there's just a few too many things going on in there to make the whole thing safe. And just kind of accept that, just like we've tried to make the whole thing const in there, and you can get about 95% through making things const, and then there's something down at the bottom which is mutating things, and you could fake it with a cast, but
there's a question about standard v2. Is it intended to be no GC?
I think it's a hope. Right now I'm more focused on how do we make it actually happen so that you can have both the original standard and the standard v2 in the same binary.
Well, there's very little in Phobos 1 that actually requires the GC. So I think that we can do STD2 and have it pretty much be no GC. Maybe not entirely, but...
We should make it as no GC as possible.
That's right. One thing I've talked about before, but hasn't really caught on, is the idea of, rather than having the library decide how memory is allocated, have the user decide how the Phobos routines are going to manage memory by passing in what Andre would call a policy, which is how do you allocate memory. And that would push the decision onto the user instead of the library having to make that decision.
We had a question for you earlier, Walter. Some good rules for pull requests are to make them as small and focused as possible and to separate refactoring from bug fixing. Sometimes, though, the problem is complex, and so is the pull request. What do you think about organizing regular, for example, weekly, bi-weekly video calls for code review between the author and available reviewers for bigger DMD pull requests? If the pull request is touching the DMD backend, your input there could certainly be helpful.
Well, I would kind of like to not pull the rug out from under our new PR managers before they even get started. So I don't want to weigh in too much with this is how it should be. But one thing I find very useful is sometimes years after a PR's been pulled, there turns out to be a problem with it. And when you go back and look at the review comments in the PR, you're often, or at least sometimes, able to get clues as to why the thing is the way it is and potential problems with it. And I'm kind of concerned that if it was done over a video chat, all that context would be lost, and you'd be looking at a PR completely baffled what it is or how this thing managed to pass the review process or something like that. So that's kind of a downside to it. I really like the ability of GitHub to keep a record of these conversations and the review comments on something, because I'm often, the person who made the pull request, may have lost interest in D or just decided to move on, and they're gone, and it's a large, complicated pull request, and I'm looking at it because there's a bug in it and having no idea how the pull request thing worked. How did it get through the review process or anything about it? So sometimes there is a debate in the reviews of the thing, which helps a lot. And if it's done verbally, all that information is lost. So I guess I have a problem with that.
Is there a roadmap of what standard allocator needs to be production ready?
I'd kind of defer that to Attila and Steve. I'm not a heavy
no
user.
idea.
Yeah, okay. So
I
guess
used
we'll
I used
clarify
allocator
that.
in iopipe, and I found that I actually had to write my own allocator for the GC because it was allocating all my ubyte buffers with as containing pointers. So I think it still needs some attention for that aspect, at least. Like it doesn't interact with the GC perfectly. But yeah, if you had that, and so you could like say to set your default allocator, now you've just communicated with Phobos. This is how I want you to allocate things.
I want to expand a little bit on what I was saying about the pull requests. Where the verbal thing can really help is if two or more reviewers have intractable difference of opinion about how to proceed. Then sometimes it just doesn't work to keep reiterating back and forth in text, and it's time to do the Skype call or the team meeting or something then to try to figure it out. Or worst case to worst, then you defer it till DConf, and then you all sit around with a beer and hash it out. I've found that really works on the most intractable of differences, is to sit around the table with the beer, and you can almost always get it resolved that way. That's an exception to the, text reviews.
All right, Steve, thank you very much.
Thanks. It was good.
Enjoy BeerConf, man.
I plan it.
Bye-bye.